Welcome back, and in this last video in the groups 1 and 2 topic we're going to be looking at flame tests. You need to know the flame colours for the different compounds, but you also need to be able to understand why different elements or different ions produce different colours. So we're on page 17 of your notes and we're looking at this flame test that you're going to do in class. A couple of very important things that you need to be aware of and need to be able to describe if you're asked how you would carry out this experiment. Firstly, you need to use a nichrome wire. That's a nickel chromium wire. The reason we do that is it won't contaminate and it won't give a flame colour itself. So it's very important that you use the correct wire, nichrome wire. You dip that in concentrated hydrochloric acid. We would then usually clean it in the Bunsen burner flame until you see no residual colour. Then we dip it into the acid again, then into our crystals, and then generally speaking we put it into the blue part of the flame. We don't put it in the roaring part, we just put it in the blue part, and we write down what colour we see. So you need to just be a little bit careful. The hydrochloric acid is quite a strong acid, it's quite corrosive, and the wire and the rods will get very hot. So you just need to be careful of that. So here are the accepted colours for the flame tests. And you need to learn them. Now the ones in bold are the ones you need to know for your exam. We have put just a few extra in there like rubidium and cesium. Now there are 3 flame colours which are reds or yellow reds. So that would be lithium, calcium and strontium. So you would need a different test or some way to distinguish between these ions. Please notice that calcium in your exam board is yellow red. You may have learnt it at GCSE as crimson or something else, but please watch that. It should now be learnt as yellow red. The other thing you should notice is that magnesium ions do not give a flame colour. Now do remember we are heating ions, not the elements. So magnesium metal burns with a very bright white light, but magnesium ions do not give a flame colour. And we're going to explain why that is in the next section. We need to be able to explain why different ions, different compounds have different colours. And it links back to the electron structure of our atom. So if we think about having a basic atom, so I have my electrons in my principal quantum shells. So I'm going to show them like this. Oopsie. All the way around. So I have an electron in one of my energy levels. As it's heated, that electron will gain energy and jump to a higher energy orbital or a higher energy level. So that's what the flame is doing. It's taking that electron and it's pushing it up to a higher energy level. And that will absorb energy. As that electron drops back down, it will release energy. So this is where I get my photon. So the energy being promoted to the higher energy level, it's unstable in that shell or orbital. So as it drops back down to the lower energy level, it will release energy in the form of a photon. Now the gap that it drops back down, that will give me a specific frequency of light. So this helps us to explain why magnesium does not give a flame colour when you heat the compound in a Bunsen burner flame. The electron is still being promoted to a higher energy level. The electron is still dropping back down. However, the photon that's being released is not in the visible part of the EM spectrum. So it's outside of that visible range and therefore you don't see the process going on. So this, what we call quantum jumping, is still happening. The electron's still being promoted and still crashing back down, but the photon being released is not part of the visible spectrum. So we can see that if we look at the absorption or the emission spectra. So we have the absorption and emission spectra of hydrogen here. So this, if you like, is the energy supplied by the flame, and these black lines represent the energy being absorbed as the electrons are being promoted. But in a flame test, what we actually see is the emission spectra. So what we see is the electrons dropping back to their lower energy level. And that's when we see these specific lines. Now, our eyes interpret this as one single colour, but if we were to split them up using diffraction grating, we would actually see these lines. And if we were to do this with these elements, or the compounds of these elements, you would see bright lines in the yellow region for sodium, the green and the yellow for barium, and the red region for lithium, and that's why we see those colours. Another way to represent this would be on one of these diagrams, where I have my electrons in my principal quantum shells. When I remove an electron, I take it to infinity, but as it drops back down, it will release energy of a particular frequency. So each of these energy changes will release energy of a particular frequency and will be seen as a line in an emission spectra. So that finishes this section of the notes, just looking at the flame colours. And that in fact finishes all the notes for groups 1 and 2. Make sure you use the specification statements on the front cover, gone through them and check them very carefully. Make sure you're happy with everything, especially describing the thermal stability of the carbonates and the nitrates. So until next time, take care, stay safe, bye-bye.